Or Aaron, me, and Udayan.
Me.
Yeah. We'll cover a singleton, GameManager, scene loading, Unity attributes, prefabs, preprocessing, editors, coroutines, null conditional operator, commenting, and renaming. It sounds like a lot. Yeah. Okay. So now we're going to be doing all this inside a Unity project. So I made one beforehand, and I'm just going to kind of walk through everything.
Is it a blank project or something?
It's something pre-built.
Okay.
Yeah, mine's pre-built, but I'll walk through how I made it. It's just so I wouldn't make any mistakes while going back through it. Alright, so when creating a Unity project, this is a 2D project if anyone wants to copy what I'm doing. Alright, when creating a project, one of the first things you want to do is set up your asset folders. You start with the scenes folder already there, but you'll want to make a scripts folder to put all your coding in, and then in scripts you may want to add a couple of subfolders possibly if like there's specific groups like
Have them like enemy AI, for example.
Yeah.
That's like its own separate folder.
Yeah. And then controls, if you're using the new Unity input system, that'll be used to put your controls object in for when you're editing player movement and such. And then resources. This is basically everything else. Because when coding in Unity, Unity has a shortcut for loading resources from code called resources.load, and it can be used to load anything within this folder. So the resources folder is extremely important if you want to load anything from code, like load assets or anything, because the command resources.load or .load all or load can be used to load anything within that folder without having to do assets/resources/ and so on. It's a very helpful thing, and I'll show the actual code later. Alright, and then so the first thing I did was I made a menu with a beautiful start button. Yeah. I didn't realize the start button was that big, but I made this on a different computer. So scaling, that's not something we cover in this workshop. Alright, so to create this, I just added a canvas object, which can be added through UI and then canvas, right here. And then I added a button that just says start. Very simple. The start button references a script called scene loader. It's a very simple script. You have to use the Unity engine.scene management, and then you just have one method called scenemanager.load scene, and then an integer. That integer represents a build index, which, let me go into that real quick. The build index, when building your Unity project, you have the build settings, which have scenes within it. You have to add scenes to that, and then the build index is can be used to reference which scene you want to open next, and it can be found on the far right side of the build settings. So whenever you have a new scene, you can just do add open scenes, and it'll add it at the bottom of the list, which is how I got these scenes on there. Okay, to call the scene load, you can do a button on-click event for a button. This is a built-in feature of UI buttons. If you scroll down, you'll see an on-click on the inspector, and then this is what it will look like for you when you go to add it. And so what you want to do is add the scene loader script to an object within that scene. I added it to the canvas, and then I dragged the canvas. Oh, God. One sec. you drag the canvas into this object, and then you're given a couple different options for what you want to access within that object. So what we want to access is a scene loader script, and then within that script we want the load scene method. And then you can enter the integer number for the scene you want to load, which is 1, because that's the first scene. And so then if you run it and hit start, it loads a new scene.
You show the game manager.
Oh yeah. Next we have a game manager. Oh yes, sorry.
So are scenes kind of similar to like rooms in GameMaker?
Yeah, it's like a level.
Yeah.
Mm-hmm.
Okay.
Yes, I haven't used GameMaker, but yes.
Okay.
Yeah. So yeah. One thing you need to do if you're going between scenes is have a game manager. Game managers are useful for storing all your information and keeping it between scenes, because otherwise everything gets destroyed on the scene change. So with the game manager, it'll use what we call a singleton structure, which some of you may know from your coding classes. So should we do this?
Yeah, for the instance.
Oh yeah.
Yeah. So with Singleton, you would have one instance of a project or of a manager in this case. So what we're doing here is we have a reference to a static game manager object, and that's our instance. And then this, when we awake the game manager, we're actually setting that instance to the current game manager. And then, so what we can do with it is, let's say we need to call some global like method. We can just do GameManager.instance dot whatever method we need to call. So I'm trying to see if we have
One of the scripts should have a reference to it. I think text center. Yeah. So game manager reference to the script.instance, which then calls the get number method. And just a little explanation of this get procedure. So when you call GameManager.instance, it'll check. Well, I guess I'll explain it in order. So application quitting. This is a Boolean I added that checks to see if the game is ending. So if you're quitting the program, it'll set this Boolean equal to true. And this is useful because at least so in my personal project I'm working on, I was just I had a game manager and I was referencing it in an onDestroy method, and that onDestroy method would be called after the game manager had already been destroyed. So when you call the instance of a game manager, if there isn't one, it creates a new one. So that was a problem because it would just continually create game managers, and which wouldn't be destroyed at the end of the program. So this checks to see if you are currently closing the program, and if so, it will return a null value, so you don't have that extra creation of a game manager. Then, if there is no game manager, it tries to find one within the scene. And if it can't, it creates one with a new empty game object. It creates an empty game object and adds the game manager script to that object. And then it returns that the instance of the game manager. When game manager is awake, this method is a listener that checks for whenever application.quitting happens, it sets the application quitting to true. And then instance equals this will instance equal this will set the game manager instance to be the current object. And I just realized I forgot something in this. Alright. Oh, and then don't destroy on load. Make sure that the game manager does not get destroyed when the scene is changing. Don't destroy on load will make sure that the game manager and all the properties held within are kept when scenes change. What I needed to add was if instance does not equal this, that's to check if there's already a game manager within the scene, then destroy this. That way, if there is already a game manager in the scene, it'll destroy the newly created one and won't have duplicate game managers. Okay. What do you want to cover?
Do you want to go to the next scene?
Oh, the next scene. Okay. So, to kind of show how it keeps values across scenes, we created a little thing. So the game manager can hold a number, as you see, and which we set in this scene. And then, if we start this scene, wait, actually I think the other scene was broken due to, hold on.
Scaling off.
Yep, I have a much larger monitor than computer. Than laptop. Let me change that. Yeah. Canvas. Do.
Oh, it's gonna be.
Yeah, it'll be fine. Okay. There we go. I'm just rescaling some stuff. Okay, now it should be good. So anyways, we start the scene that holds the game manager with the value of 6 to 9 held inside of it. We start the program, hit start, and then it doesn't work, as coding does. Yeah, so that was nice. This was working the other day.
Yeah, that's a book thing. The other one.
Oh, the other one?
Mm-hmm. What is the numbers you're connected to?
This.
Text editor.
Okay, text editor. So now we go into the process of debugging.
Yay.
Alright.
So.
Huh? Well, you see, it's not displaying what we wanted to display.
Yes.
Oh, wait, is it destroying it, maybe?
That might be the case. Human was. Maybe she says that doesn't maximize. Alright, so.
Okay, start. No, still. What is that game object? Oh, wait, no, I was just drawing it.
So, you just want to comment on.
Oh, wait. So, if this is not equal null, and there we go. Oh, wait, no, that should be, sorry, that should be instance. Does not equal this. Now it should hopefully work. Okay. Yay!
Yay.
We are good at what we do. So now it displays the number in the text box.
Mm-hmm.
Yeah, showing how it keeps values across scenes.
Okay. Alright, and explain the tooltips?
Oh yeah, tooltips. Oh yeah. So a very important thing within coding, especially coding if you're on a team, is Unity attributes, which are these brackets you see up here, which are like tooltips. So you all are probably familiar with commenting from coding classes and such, all of our favorite parts of coding, commenting every single method. And that's what this is. Tooltip will display information about the variable when hovered over within the editor. So if I go to the game manager and hover over number,
it's a private variable, so you shouldn't be able to see it in most cases, but because we have the serialized field, you can now see it and also edit it while inside the inspector.
And also the tooltip is displayed as number to display. Very creative tooltip. But yeah, what Udayan was saying was serialized field allows a private variable to be visible within the editor. This is very useful because you don't really want to make all your variables public so they can be accessed from other scripts, because that can just cause problems with your code. So if it's a variable that is only used within this script, you should really make it private and then serialize it, allowing it to be edited in the editor but not from other scripts. Alright. And then some other tool Unity attributes are okay, here. Header, which will put a let me open the scene actually. Where is it? Oh wait, I think it's on this. Yeah. Nope, this doesn't have the header. Oh wait, no, it's on the prefab. Resources, prefabs. Okay. So this, as you can see, has a header right here that says size information, which is added through the header attribute. So it'll add it between the variables that are listed there. And then there's also range, which makes it so that it gives you a line to set the variable. This is used for integers mainly. So it's currently set to 10. But if you pull along the line, you can change it to whatever you want between the values that you set within the code, which are currently 0 to 10. So yeah.
Remember for descriptive action.
Oh yeah. Alright. Well, actually, I think maybe prefabs first because
yeah.
Alright. So this is what we call a prefab. You want to talk about prefab?
Yeah. So whenever you're creating a game object, something that's going to be made a lot, like maybe a rock or an enemy, or even just something that's easily like or even like a room space, you can need multiple objects. You can drag that game object in. So I think in our scene, we don't actually have an enemy in our scene, but what we did was we created one, like I said, like a cube. I could take this cube, put it in the prefab, easy peasy, and then come back to a different scene and then drag that back in perfectly exactly the same. There are some faults when you're using scripting depending on what it's connected to. So for example, if you have it connected to like a main camera, there are different main cameras in every scene. You might need to reconnect it. So in this case, with our enemy spawner, what we're doing is within the spawner, we are calling that prefab, and then we are instantiating it in the code, which means it's creating a clone of it. So, for example, if we play it, oh my god, the scaling's off.
Oh yeah. Okay, wait. I can mess with it real quick. Okay.
Probably need to change the range, right?
Probably. Wait. What happened? I'm gonna go into the scene view.
This wasn't. Yeah.
Large. Okay.
Begin. Alright. Yeah.
Nice and large still. Alright, let's go 0.5.
And that's why having a serialized field is useful. So you don't have to go back into your code and you open up Visual Studio over and over again. Or go back and forth.
Nice.
You can spam it if you want to.
Okay, wait, let me do this actually.
Oh, yes.
I think the size of the sprite in the prefab is
Probably, yeah.
It's supposed to match the flag
Oh, how the hell did he get that big?
Kind of thick. They can just click on it, Collider.
No, what I'm gonna do is remove component and back. And now it's the size of the new sprite. Okay. Nice. Scaling is great. There we go. Yeah, so spawn enemy will spawn a dude. And then you can spawn multiple dudes. And they fall out of the world.
Yeah.
Because this collider is also messed up. Component. Yep. There you go. Yeah. Spawns an enemy. Okay. Oh, let's just do coroutines, I guess.
Oh, yeah, coroutines.
Alright, so what we added to this dude is a coroutine to change the size of the guy. Okay. A coroutine, to create a coroutine, it's like a method. You do enumerator and then whatever you want to call it. And then within that, the most important line is this one right here. You return new wait for seconds. This will basically stop this method for however many seconds you say in here. And then once that amount of time has passed, it'll continue. So the way we're currently using it is we're starting it at runtime, and then every, I think, 5 seconds currently.
3 seconds.
3 seconds.
I don't know. That's never fine.
It changes the size of the enemy, and then it calls. Once it changes, once it waits, it calls itself again to do the method over. So it's like update, but it's called a lot less often. So rather than having to add up like delta time and update to see if it's reached 5 seconds yet, you can just wait for 5 seconds and then call itself again. And so that will change the size of the enemy, which we can see trail someone in here. But yes.
A question about coroutines. Is there a limit to how many you can have in the script? Like you have just one or two?
You can have multiple. Yeah.
Yep, there we go. And then it changed size to cute, to huge, to breaking our code. Because scaling. Fun stuff. Right. Oh, also, in this script, I noticed I forgot to attribute. Hide in inspector. This is if you have a public variable you do not want to edit in the inspector. So it'll make the inspector less ugly looking. Yep. Exactly that. Opposite of serialized field. Okay. Oh, let's do the editor. So we have a thing. You can edit the inspector to customize it in different ways. So, as you see here, the wait seconds has the attribute hide in inspector. But if you go to the enemy thing, hide wait seconds is visible right here. That is because we created a custom editor for enemy size. What you do is create a script, and then instead of mono behavior, change it to be editor. And then above that, you do custom editor type of, and then the name of your script, which is enemy size in this case. That will make it so any object that has that script on it will follow these editor rules. So on inspected GUI, which is like when it's opened up, this will call the base method so that it will draw it as normal. And then after that, you can add on special stuff. Target, you can cast target to the type of script it is, and that'll get you the current instance of the script attached to this object. And then, so say we wanted, right here, we want to have wait seconds become visible within the editor. So what you do is script.waitSeconds equals, and then a editor GUI layout dot float field, because the value of wait seconds is a float. There's also int field, bool field. There's just fields for all the value types. And then what do you want to be displayed in front of it, like the name of it, you know? Right here, wait seconds. And then the variable you want displayed. You can also add buttons to an editor, which is done here. It's put in an if statement so that whenever the button is pressed, it'll call everything within that if statement. You can do this for, like, one of the things I use it for is I have a tile map that I have a bunch of tiles in, and once I finish making the map, I want it to be converted to a text file. So I press the button, and it goes through and converts everything in the tile map to a text file. Right now, we just have it printing out hello world. So you can go to the enemy and press the press me button, and it will say hello world in the debug. And the statement you want on the button can just be seen within these parentheses, press me. So yeah, a lot can be done with editors. This is just like a small glimpse of what can be done. They are really good, and I really suggest you look more into them. They are very helpful. Next, we have, what do we have?
No conditional operator.
Oh, yeah, that's the question. Text editor. That's this, right?
Yes. So whenever you want to deal with like an object that's null and you're unsure of it, all you have to do is just put a question mark at the very end, and it'll just make sure that if it isn't null, you can run the method as usual. But if it is null, you don't have to deal with some crazy error. Just ignores it. So I think we handled singleton. Anything else?
Yeah.
Preprocessing. Yes.
All right. So, next we have the we have preprocessing.
Yes.
Yes. Which can be used if like you import assets. It can mess around with the assets before it actually adds them to the asset library. So, such as so you create a script and then change from mono behavior to asset post processor, and then you have to use Unity editor, and then from there you use the void on preprocessed textures if you want to mess like with a sprite. Like say you have a game where you're using pixel art, and you want all the pixel art to have the same like pixels per unit, you know? It's annoying to have to import the asset, then go into the asset and change the pixels per unit manually, and then also the filter mode manually, so it isn't all blurry if you scale it up. It's a very annoying thing to do. So this will take in the asset importer is a built-in variable for asset post-processor, and then you can convert that to texture importer, and then from that importer you can change the filter mode to point, or like the sprite pixels per unit to 32. You can just mess with all the settings of the sprite, and then after it's imported, it'll have those new settings. And you don't have to go in and manually do it. Yes.
Does that only apply to like newly imported assets or like anything?
Newly imported.
I think it's only newly imported. Yeah. You can also use it for things other than just sprites, such as there's a way to do it for prefabs.
You do it for like FTXs or
FTXs,
audio, anything
audio.
that just can be imported.
Anything imported can be used like this. Like, I think it's object importer. Oh no. What is it? There's different things. Oh, I forget them currently. But there's a couple different things, such as if you're importing a 3D model, you can edit the settings of that 3D model and through this.
I think it's model importer.
Oh yeah, probably. Yeah, model importer. So you can import a model importer, and then this will only be called if the thing is actually a model. So if importer does not equal null, so like if it is a model, then it'll do any code you want it to do. And that's in the on preprocess asset method. I know there's some other stuff in there.
That's funny, yeah.
Oh yeah, instantiated.
Or did I already? Well,
I don't think we showed actually instantiate though.
yeah, we needed it. Yeah.
Yeah, because it's in respawn. Alright, so for prefabs, you can spawn them into the scene using instantiate. You just do instantiate the game object or prefab you want to spawn into the scene, and then you can include a transform of a parent. So when it will spawn in the editor, okay, so actually let me just run this. So we have the parent currently set to be parent object. So when we spawn an enemy, you can see it automatically is listed below the parent object in the scene on the format. That is very small. Oh my gosh. Okay. So yeah. Oh yeah, renaming. Okay. This is just a general thing. If you want to, like, so this script is called enemy color editor. That's because originally we were going to try to change the color of the enemies rather than size. So we want to rename it. We can double click the name, right click and click rename, and then change it to be enemy size editor. And this changes it in all references to this, and also in the Unity, in Unity itself. While if you renamed it manually, you'd then have to go into Unity, change the name in Unity, otherwise it would throw a bunch of errors, because the script no longer exists. So yeah, enemy size editor is now changed to enemy size editor.
Did you want to show the next
Oh, I think we covered everything on here. Anything you guys want more clarification on? Yes.
I have a unrelated question.
Mhm.
Why is GameManager script? Why is icon on instead of the C# script icon?
Oh, Unity just if you name a script Game Manager, Unity automatically switches it to be the gear.
Oh, it's because it's special.
Yes.
Yeah.
It's a cool little feature. Alright. And then these are all the Unity attributes you can use. There's a lot of them. I don't know all of them. But yeah. Let's see. I'll go to try to see if require component. Right. You can add that to the top of a script, and when you add that script to a game object, it'll automatically add whatever components are required. So if you have a player like combat script, and you want to require a box collider on that player, rather than adding both those components individually, you can drop the script on there with the required component, and it'll automatically add a box collider onto the game object. Very helpful. It also makes sure that if you're trying to reference a game box collider or whatever on that object, that it never fails because there isn't one. Let's see. Serialized field.
Yep.
Important.
Execute always, or execute in editor mode. Edit mode. Yeah. So there are certain times where you just want to have something only in the edit mode, but not in the a final build. You can always just put execute in edit mode, and it'll always be there. Or the other way around, you can always have it execute all the time, just in case.
Oh, space. This just adds a space in the editor. Right. If you want to have a blank line between different variables in the editor, so it's easier to spot the difference between them, separate different sections, you can just add a space. And then you can say how big you want that space to be. I don't know the limit to that. There probably is one.
Mm-hmm.
But yeah.
Multi-line. Multi-line.
Oh yeah, isn't that for text input?
Yep.
Yeah. So if you have a string field in the editor, it'll have instead of just a line that will go on for a while, and hide a bunch of your text, it'll have a paragraph box instead of just a line box. So it's easier to see in the editor.